Okay, so pretty much what we did was first we we made an in-out table. That's our beautiful in-out table. And at 1 it was at 2:36, so we plotted all of those points and we found out that the rocket will reach its highest point at 3 seconds.
For the first question, the rocket will go 292 feet at its highest point. On the second question, the rocket will be in the air a total of 7.25 seconds. On the third question, we used Hanna's formula by plugging in the time into an in-out table.
Very good. Good job, group. Next.
Alright, the first thing we did was write the formula down. And then we plugged in these numbers into this equation to get points on our graph. A little graph there. Okay, number 2, we kind of reinstated their questions. And how long will the rocket take to reach the top? Just 3 seconds. How high will the rocket go? 292 feet. And how long will it be in the air? 7.149 seconds.
And then for number 3, we plugged numbers into Hanna's formula to get the points for our graph, which helped us answer the questions.
Very good. Beautiful job, group.
Okay, to start out making our table, we did an in-out table, and so we found out that it starts at 160, and we wrote down our formula, and whatever our time was, like, we plugged that in for t, but then we'd square our time, not the 16, like if you were going for 1 second. And then we made our graph by using our information and our equation, and that's how we found our graph, and the highest point to be at 3 seconds, which is 292 feet.
The questions that we had to know are when the rocket is at the top of its flight and how high it goes and where the best place to stand to watch it is.
Okay. To use her equation, you just take all of the t's and you plug in whatever number you're looking to find. So with the seconds, if we're looking for 2 seconds, we just plugged in 2 for the t's.
The fire, and based on what the graph says, is the highest the fireworks will go is at 3 seconds, and which is how long they usually are, and that's all.
Alright, for ours, the equation we did the in-out table, so you plug in like 1, for example, you do the equation of when you get to a t, you put in like 1, and then you get to another t, you put in 1 to get your answer, and you just do that throughout the whole in-out table.
And for number 2, we said the rocket will be in the air for about 7.5 seconds. The highest point will be at 292 at 3 seconds, and the rocket will take 3 seconds to reach the top.
We used her equation where we would plug in the numbers wherever t was, 3 and 3. And then to solve it, we used the in and out tables where we just plugged in the numbers.
And it's all clearly demonstrated here with the starting point at 160, the peak at 292, and it ending at 7.25.
Very good, group.
Okay, well, this is our graph that we used, and our questions that we needed to ask were how long the rocket will take to reach the top, and how high the rockets will go, and how long the rocket will be in the air.
And then we used Hannah's expression by putting in the amount of seconds, which is right here, in for t, and then we solved it, and this is our in-out table.
So based on that, it takes 3 seconds for the rocket to reach the top, and the rocket will be in the air for approximately 7.148 seconds, and the rocket will go 292 feet in the air.
Beautiful job, group. Next.
Well, h equals 160 plus 92t minus 16t squared. And our in and out table was in was 1, and our out was 236 and 2 and 280 and 3 and 290 and 4 and 272 and 5 and 220. And 3 and 290 was start because it was the biggest out. This is 290. Smaller.
So using the points that we got from our in-out table, we were able to graph them, and that way it would show the log curve, that kind of graph, bone shape. And we used this equation to get those points as well, and there's that.
So, how long will the rocket be in the air? It'll be in the air for 3 seconds, or that's the highest point, but it'll be in the air for about 7.25. And we substitute a t for a specific time in order to find the highest point, or the points you want to find.
And then to show our work for finding out how long it was for 1 second, we took the formula, which was h equals 160 plus 92t minus 16t squared. We substituted the variables in for the time that we wanted, so 160 plus 92 minus 1, or parentheses, minus 16 times 1 squared. Then after that we solved it, it was 160 plus 92 minus 16. After that it was 160 plus 76, and our time, or our distance was 236.
Very good.
Okay, well we wrote down the formula, which is not on here, but then we plugged the time into it, and we found that 2.9 seconds was the maximum trajectory it would reach. And then we also tried 3.1, which is 2.9, so 2.9 is the maximum trajectory. Take over.
The questions that we needed to answer were: how long will it take for the rocket to reach the highest point in its trajectory? How long will it take to, or how long will the rocket be in the air, and how high will the rocket go?
Now you have to plug in the number of seconds where t is, and you get the height it would reach in those seconds.
To answer the questions, 2.9 seconds is the highest point. The rocket will go 292.24 feet. And all these is the in-out table for where it will land. I mean,
how long it'll be in the air
after
before
how
it touches the ground?
long it'll be in the air before it touches the ground. And that's somewhere around
7.14599999999.
That's how long
9,
it'll be in the air before.
Very good.
There's a lot more 9s in there, but
Good work, group.
We gave up on the 9s.
Good job. All right. Every group said that 3 seconds was your how long it took to get to your peak. Besides their group, they said 2.9 seconds. Who's right? How come nobody else decided to check any other times?
because I did that myself, so I was curious.
Okay. You guys checked 2.9 as well as 2.8.
2.8, 2.1.
Did you do 2.85?
Yeah, we did 2.9. We did like 2.95 and all that.
Okay. Okay. So they checked the different values. Who do you think is closer? They are. Okay. Soon enough, we'll figure out an algebraic way to solve it. Right now, we had to use guess and check. What did you know about your equation? Did you know the h or did you know the t when you were trying to figure out how long it took to hit the ground? You knew the time? We knew how long it took to hit the ground?
No, you knew the height of it.
You knew the height. You wanted the height to be what? 0. So eventually, we will figure out when the height is 0 without guess and check. Beautiful.